In the previous class, we discussed behaviorism, which dominated psychology for nearly half a century. Behaviorism claimed that what goes on in the mind is not important, our behavior is simply a response to the external environment, concise and practical. However, when applied to real life, it raises some questions. For instance, if a child studies hard, and we observe that everyone in their family excels academically, behaviorists might say it's because of the environment that the child learned and maintained the behavior of studying hard. But we can't help but wonder, if we place another child in the same environment, will they also study hard? Does the individual's willingness, ability, and preferences not matter? Conversely, if it's the same child placed in an environment that doesn't value education, does that mean they won't study hard? His reflections grew, and in the 1960s, a voice emerged in the field of psychology, overthrowing the 50-year dominance of behaviorism. This movement was called cognitive science, and at the time, it was known as the cognitive revolution. What remarkable changes did cognitive science bring about? In this class, I will introduce 3 aspects to you. Studying the subjective world with computer models. Remember, according to behaviorism, human behavior is a simple response to external stimuli, and what happens in between is unimportant. Cognitive science, on the other hand, disagrees. It aims to study the subjective world of humans. How is this studied? Through the use of computer models. This is not surprising, given that cognitive science emerged in the 1960s, a period of significant developments in American computer technology. Equally unsurprising is its origin from a computer scientist, Herbert Simon, also known as the father of artificial intelligence, who had received a Nobel Prize. In 1956, Simon introduced a computer program called the logic theorist, capable of mathematically deducing logical propositions. Although it dealt with simple propositions, it shook the scientific community because, historically, logical deduction belonged to the realm of philosophy, a cognitive activity exclusive to humans. Now, computers could do it. This inspired 2 young professors from Harvard's psychology department, George Miller and Jerome Bruner. Intrigued, they began to wonder, is the human brain essentially a computer? The operations of a computer are complex, but the principles are simple, 3 steps in total: input information, undergo computation, output results. Its core is called an algorithm, the process that converts input information into the intermediate steps leading to output results. Of course, the human brain is not an ordinary computer. The amount of information it stores and processes is incomparably more complex than a regular computer. However, the essence remains the same, transforming the vast world into signals resembling mathematical symbols, storing, calling, and calculating according to specific algorithms to achieve various advanced psychological functions. To confirm this hypothesis, Miller and Bruner established the Harvard Cognitive Research Center, incorporating disciplines such as computer science, artificial intelligence, neuroscience, logic, and psycholinguistics. This initiative marked the beginning of the cognitive revolution. To this day, the revolution is ongoing, and cognitive science continues to be mainstream in research institutions and university psychology departments. If you're interested in pursuing an academic path in psychology, I recommend delving deeper into this field. How cognitive science helps people. Now, let's discuss how cognitive science helps people. This is not an easy question to answer. On the surface, cognitive science's task seems to be merely studying the processes occurring in the human mind, seemingly not directly conducive to helping people. However, the idea of algorithmizing and softwareizing mental processes provides a perspective for self-improvement. Before the cognitive revolution, mental abilities were considered innate and difficult to change. However, if viewed as a set of computational processes, it significantly increases human subjectivity. For instance, children growing up in similar family environments may develop entirely different personalities. 2 brothers raised in a household with parents who have a bad temper and often quarrel may respond differently. The older brother, displaying a temperamental disposition, attributes it to learning from his parents' interactions. In contrast, the younger brother, adopting a gentle and courteous demeanor, claims to have experienced the hardships of the family and wishes to avoid repeating them. Despite attributing their behaviors to the family environment, they are using different algorithms to process the stimuli from their upbringing. Individuals have the right to subjective choices, even if we can't change the environment, we can choose to become better people. Cognitive science also offers a new approach. We can focus not only on upgrading the hardware but also on optimizing the software. What do hardware and software mean? Let me provide an example. The American psychologist George Miller discovered that human short-term memory has a limit, known as 7 ± 2. This means that if you are asked to remember an irregular sequence of numbers, say 3497652, and then recall it, you can generally remember only about 7 digits. If the number is more complex, like 34976529188250016, it becomes challenging to remember. Humans typically retain around 7 digits. However, the algorithm can be changed. Miller found that the memory limit is not 7 digits but rather 7 chunks of information. These chunks can be understood as information blocks, each containing several digits. For example, taking the sequence 34976529188250016, breaking it down, 349 can be considered a single number, 765 is another, easy to remember. 2918 conveniently aligns with multiplication tables, 825 can be remembered as August 25th, and 016 can be associated with the year 2016. In this way, you only need to remember 5 numbers, 349, 765, 2918, 825, 016, much simpler, thanks to algorithm optimization. In my field, psychotherapy, for conditions like depression and anxiety, if we consider them as sets of algorithms in the mind, we observe that depressed individuals tend to remember negative and failed experiences, while anxious individuals quickly capture stimuli they perceive as threatening. This leads to intervention strategies. For instance, some people become excessively nervous in social situations. I designed a simple program to train them to quickly identify friendlier faces in a crowd. The results showed that after just a few training sessions, their anxiety significantly improved. Philosophical consensus at a new level. The final point I want to emphasize is the value of cognitive science at a philosophical level. It has led to a consensus that the subjective world of humans can be objectively understood. I recall my first cognitive science experiment, asking participants to judge whether 2 letters on the screen were the same. They could be the same letter with different cases, like AA, or completely identical cases, like AA. This judgment wasn't difficult, taking less than a second. However, if the 2 letters had different cases, the judgment was slightly slower than when they were the same. By how much? 74 milliseconds, less than a tenth of a second. Through this slight delay, we could observe a sequence in how humans process information. Judging 2 identical as only requires visual image matching, while judging an A and an A as the same letter involves invoking more advanced semantic cognitive processes, causing the delay. After completing this experiment, my most frequent question was, what's next? What's the use of making this process so clear? One day, it clicked, and I realized that the real value lay not in this specific conclusion but in the countless similar conclusions. Before the cognitive revolution, how did we imagine psychology? Freud likened it to an iceberg beneath the surface of the sea, mysterious. It's akin to describing our bodies in an age without anatomy, envisioning concepts like yin and yang, or an invisible qi flowing through meridians. It wasn't until physiological anatomy emerged that we believed those mystical experiences inside our bodies weren't metaphysical but objectively knowable. Psychology underwent a similar transformation. Whether you're aware of it or not, you've accepted the most significant impact of cognitive science, the belief that psychology is fundamentally an objective, concrete computational process. Psychology isn't so mystical, our brains are nothing more than machines running algorithms. This is a demystification at the level of our understanding. On the surface, this conclusion might seem disheartening. Yet, if we think of the mind as all-powerful, we risk placing unnecessary pressure on ourselves. Why am I so clumsy, so miserable, so incapable? Why can't I be like others? These pressures not only hinder our progress but may lead us into a vortex of self-blame. Now, everyone can calmly tell themselves, it's not my fault, it's just that different algorithms formed in my mind. The more objectively we view our psychological processes, the more we can accept our shortcomings while finding directions for change. To summarize, cognitive science represents a profound transformation in the field of psychology. Utilizing computer models, it views human psychology as a set of algorithms processing external stimuli. Here's a question for you. In this class, we discussed many contributions of cognitive science. Do you think this field has any limitations? Feel free to share your thoughts. In the past few days, we've explored various schools of psychology. In the next class, we'll delve into humanism, marking the final stop in the concise history of psychology.